Hello everyone, my name is Patil and I am from RBNB College, Srirampur. As in previous videos, we were discussing about our chapter Modern Periodic Table, in which we have seen the different characteristics and according to the blocks and the periods and group wise also. Then next we have seen some interesting concepts that can be seen in the Modern Periodic Table and few trends. Now the remaining trends we are going to see that the trend in the valency. What is the valency? The valency of a main group elements or any element can be defined as the number of valence electrons that are present in the outermost orbit, or the difference between the 8 and number of valence electron present in the outermost orbit. Why 8? As we know, in the 10th also you have seen every element shows the electronic configuration to fulfill or to complete the octet, means the number 8, and that's why the difference between 8 and the total number of valence electron, it can be defined as the valency. While looking in the modern periodic table, we can observe some interesting trend along the period and along the group. How that down the group, in every group, that the valency remains same, but it shows gradual variation while across the period. How? Look some examples, that the group number 1st, 2nd, then the 13th, 14th, 15th, 16th, 17th and 18th. These are the group number where the outermost electronic configuration we can observe. That total number of electron present in the outermost orbit is here 1, here 2, here 3, 4, 5, 6, 7 and 8. While looking toward the valency, as we have defined that it is the difference between the valence electron present in the outermost orbit, as this is the outermost orbital electronic configuration, that's why its valency will be 1, 2, 3, 4, but from here again 3, 5, it's 2, 6, here 1, 7 and here 0. Why? That 18th group elements, they are the noble gas elements which show the complete stable electronic configuration, and valency shows that for every element that how many number of electrons it required to acquire or to achieve the stable electronic configuration, like the preceding noble gas element or proceeding noble gas element. Now this trend we can see that the valency is going on increasing, but gradually it decreases also. And why this trend across the period? But while looking in the same group, for example, you can see that hydrogen, lithium, sodium, then potassium, then rubidium and cesium, that all their outermost electronic configuration is ns1, means they all have same number of valence electron present in the outermost orbit, and that's why they show the same valency. This one is the most important trend. But while looking toward across the group, across the period, that it shows the gradual decrease, and this decrease can be calculated or can be understood by the reaction of hydrides or oxide. Means what? Every element or main group elements, when they form hydride, means on reaction with the hydrogen, means there if it required one hydrogen, means let's see the example, that lithium hydride, formation of hydrides means to fulfill their valency. Lithium shows the valency of 1 and its valency is fulfilled by the hydrogen forming the hydrides. As we have discussed that hydrogen shows the variable valency, means what? Sometime by donating the electron it acts like a proton, while sometime it accepts the electron as a hydride molecule, and that's why lithium hydride, next one beryllium hydride, or boron. Here 2 boron molecule and 6 hydrogen. Why? Boron shows the valency of 3, and here 2 boron molecules will require 6 hydrogen. Next one, the most common, that is the CH4 carbon tetravalent, and it shows the most important characteristic feature in the chemistry. Carbon plays a vital role. Why? It shows the valency of 4, and it has a special magical property, that is a catenation, which offers carbon to at least donate the 4 electrons or to accept the 4 electrons, or formation of 4 bonds with the different or same atoms. Means what? Carbon can form the bonds with another carbon atom and other carbon atom also, or other heteroatom also, forming having the 4 valence electrons. Then the next one, here NH3, here H2O, here HF. Noble gas elements, they don't show any kind of reaction. Here we can see, to fulfill the valencies we are using the hydrogen, that's why they are the hydrides. Let's see, when it reacts with the oxides, means they react with the oxygen molecule, lithium oxide, beryllium oxide, again these are some oxides and hydrides, by which we can conclude that the valency it can be fulfilled by using the hydrogen or on the reaction with the oxygen, and this trend can be seen in the modern periodic table, as the valency shows the gradual decrease and increase across the period, and while going down the group the valency remains the same. Now the next trend of the modern periodic table, which is somewhat important, that is metallic and non-metallic character. What are the metallic character and non-metallic character? Simply, this can be understood by the tendency of an element either to accept the electron or to gain the electron. We have already seen accepting the electron or donating the electron element shows how the ionization enthalpy and electron gain enthalpy. Means what? Whenever any element it loses an electron, the amount of energy required to remove that electron from its valence shell or its outermost shell, it is called as ionization enthalpy. When that ionization enthalpy, we have seen the trend across the period, it is increasing, and down the group it is decreasing. How? That down the group number of orbit are going to on increasing, that's why amount of energy required to remove the electron, as the binding force between the nucleus and the outermost orbit electron is going on weaker while down the group, that's why the energy required to remove that electron goes on decreasing. Now let's see metallic and non-metallic character. If you see that in the modern periodic table, the elements metals, non-metals and metalloids, all three kinds of elements are present in the modern periodic table, where metals are distributed or placed to the extreme left in the modern periodic table. Means what? The elements of group first and second, likewise, and non-metals, they are placed to the right hand side of the modern periodic table. That's why, and the metalloids which are shown in the zigzag line, which is separating just the p block elements and d block elements, that zigzag line, those elements which are present on either side of that zigzag line, they show the metalloid character. What are the metals? As we know, metals have the good conductivity of electricity. Why? That presence of electron, they easily loses the electron and get stabilizes. Get the stabilizes means what? Metals, they are present to the left side in the modern periodic table, while non-metal, they are present to the right side. Metallic character, as we know, the metals are good conductor of electricity and non-metals are the poor conductor of electricity, but metals can form the compounds by losing electron. They can form the compounds by losing the electron, while non-metals, they form the compounds by gaining the electron. By gaining the electrons, non-metals, they already accept the electron. As their valency, we can see it is varying from the 3, 2 or 1. Means what? In their outermost orbit, there is the presence of 5, 6 or 7 electron. This shows that tendency of non-metallic elements, they accept the electron for the formation of compounds, and metals, they generally loses the electron for the formation of compounds. Another, the trend we can see that the metals, as we are looking, they loses the electron, means what? Here the metals, they are regarding to the ionization enthalpy. Their trend is completely dependent on ionization enthalpy, and here that electron gain enthalpy. Non-metallic character. When you see that ionization enthalpy, now let's see the trend. What is the trend? That ionization enthalpy across the period goes on increasing, means what? It is much more hard to remove the electron or to lose the electron from the outermost orbit while going through the period. Why? The number of, as we move on, the number of electron increases, and that's why it is going on much harder, and that's why the metallic character of an element or every element in the modern periodic table, metallic character decreases across the period. Why? Because the ionization enthalpy increases. Okay, means amount of energy required to remove the electron goes on increasing. That's why that metallic character decreases. But down the group, metallic character decreases, but down the group it increases. Increases down the group. Why? As we can see, the same reason, while going down the group, number of orbit is added up, and that's why the distance between the nucleus and outermost electron goes on increasing, which increases that tendency to lose the electron, and required energy to lose the electron will be lower, and that's why the metallic character goes on increasing down the group. In case of non-metals, we are going to see that electron gain enthalpy. We have seen what is the electron gain enthalpy, the change in the enthalpy while gaining the electron. That may be exothermic or endothermic. We have seen if that electron, gaining of electron required heat energy, means they are the endothermic. If the heat is exposed or heat is evolved, it is the endothermic. Across the period, we have seen that the electron gain enthalpy goes on more negative and down the group also, and that's why electron gain enthalpy becomes more negative, and that's why non-metallic character increases. Non-metallic character increases across the period, and it decreases down the group. Why? That values of electron gain enthalpy goes on increasing. These are some trends in the modern periodic table, and here from now you should know what are the trends, what are the important facts regarding to the modern periodic table. You should know at least that atomic number, what is the atomic number, atomic mass, and on that basis we are going to see our next chapter, that is the elements of group first and second, means the S block elements, in the next period. Okay, thank you.